Assalamualaikum and good evening to Dr. Farah and to all my fellow friends. Today we are going to present about expert software, which is Visual Prolog. First of all, I would like to introduce my group members. My name is Norafina.
My name is Nurul Filza.
My name is Nurul Farah Amanina.
My name is Zakia binti Ruslan.
My name is Suhaida binti Abdul Wahid.
Okay, this is the introduction to Visual Prolog. Prolog is based on Horn classes, which are a subset of a formal system called predicate logic. Prolog uses a simplified variation of predicate logic syntax because it provides an easy to understand syntax very similar to natural language. Prolog includes an inference engine, which is a process for reasoning logically about information. The inference engine includes a pattern matcher, which retrieves stored known information by matching answer to question. One important feature of Prolog is that, in addition to logically finding answer to the question you pose, it can deal with alternative and find all possible solutions rather than only one. Instead of just proceeding from the beginning of the program to the end, Prolog can actually back up and look for more than one way of solving each part of the problem. Okay, this is the Prolog component. Prolog's basic concept including predicate, clauses, and goals. Predicate logic was developed to easily convey logic-based ideas into a written form. In predicate logic, first eliminate all unnecessary words from your sentences, then transform the sentence, placing the relationship first and grouping the object after the relationship. The object then become argument that the relationship act upon. For example, the following sentences are transformed into predicate logic syntax. Okay, these are the differentiation between natural language and predicate logic. First example for natural language is a car is fun. The predicate logic is fun car. Next, a rose is red. Predicate logic, red rose. The last one is Bill like a car if the car is fun. Predicate logic likes Bill car if fun car.
Clauses, facts, and rules. The Prolog programmer defines object and relation, then define rules about when their relations are true. For example, the sentence Bill likes dogs shows a relation between the object Bill and dogs. The relation is likes. Here is the rules that define when the sentence Bill like dogs is true. Bill like dogs if the dogs is nice. The fact. What is now? What is no? In Prolog, a relation between objects is called a predicate. In natural language, a relation is symbolized by a sentence. In the predicate logic that Prolog uses, a relation is summarized in a simple phrase. A fact that consists of the relation name followed by the object or object enclosed in parentheses. As with a sentence, the fact ends with a period, dot. Here are some more facts expressed likes relation in natural language. For a natural language and the Prolog sentence, the example is the Bill likes Cindy. For Prolog the Prolog syntax. The example for the Prolog syntax for first example is likes Bill Cindy. Second is Cindy likes Bill. Likes Cindy Bill. Fact can also express properties of object as well as relations. In natural language, Kermit is green and Caitlin is a girl. Here are some Prolog facts that express their some properties. Example is green Kermit and girl is Caitlin.
Okay, the next is rules, what you can infer from given facts. Rules enable you to infer facts from other facts. Another way to say this is that A rule, as conclusions, is a conclusion that is known to be true if one or more other conclusions or facts are found to be true. Here are some rules concerning a likes relation. Cindy likes everything that Bill likes. Kathleen likes everything that is green. Given these rules, you can infer from the previous fact some of the things that Cindy and Kathleen like. Cindy likes Bill. Kathleen likes Kermit. To encode these same rules into Prolog, only need to change the syntax a little like this. Likes Cindy something, likes Bill something, likes Kathleen something, and green something. The symbol here is simply pronounced if and serve to separate the two parts of a rule, the head and the body. Also mean to prove that Cindy likes something, prove that Bill likes that same thing, and to prove that Kathleen likes something, prove that Bill likes the same thing, and to prove that Kathleen likes something, prove that it's green. In the same side effects procedural way, a rule can ask Prolog to perform actions other than proving things, such as writing something or creating a file.
Next is query. Once we give Prolog as a set of facts, we can proceed to ask questions concerning this fact. This is known as query, the Prolog system. We can ask Prolog the same type of question that we could ask you about this relation. Based upon the known fact and rule given earlier, you can answer question about this relation just as Prolog can. In natural language, does Bill like Cindy? In Prolog syntax, like Bill's Cindy. Prolog answer is yes, because Prolog has a fact that says so. As a little more complicated and general question, we could ask you in natural language, what does Bill likes? In Prolog syntax, we ask like Bill's what? Prolog syntax does not change when you ask a question. This is query looks very similar to a fact. However, it is important to notice that the second object what begin with the capital letter, while the first object Bills does not. This is because Bill is a fixed, constant object, a known value, but what is a variable? Variable always begin with an uppercase letter or underscore. Prolog always looks for an answer to a query by starting at the top of the facts. It looks at each fact until it reaches the bottom, where there are no more. Given the query about Bill like, Prolog will return two solutions, which is what for Cindy, and second one, what for dog.
As a conclusion, Prolog has built-in list handling, very useful for representing sequences, trees, and so on. It is easy to read and write programs which build structures. It is easy to build tables and database while a programming is running. Prolog particularly useful for database, symbolic mathematics, and language parsing applications. This is because Prolog allows impure predicates. Checking the truth value of certain special predicates may have some deliberate side effect, such as printing a value to the screen. Prolog can handling database into two types, which is static database and also dynamic database. Static database is a part of the program that is compiled along with it. It does not change during execution of the program. Dynamic database can change dynamically at execution time. Now I will show how to use the simple Prolog software. This coding consists of predicates, clauses, and goal. When we run the goal, it will show the two solutions based on the previous slide, which is explain that what Bill likes. Another example will show about the sport program. This is the coding. When we run the goal, it will show the question. You can choose either 1 or 2. If we choose 1, it will show the another question. And the last solution will show the game that we choose, that which is squash. That's all. Thank you.